Okay, hi everyone. My name is Matt Bandelt. I am a associate professor at New Jersey Institute of Technology. I've been there for about 10 years. I'll try to speak slowly given the time that we have. I think the way I got asked to present today was S802 was having this meeting talking about research and education and integrating the two. And they said, did anybody win an NSF Career Award recently? And I happened to be in the room and my hand was raised. And so what I was asked to, or what I'm going to do today is talk a little bit about integrating education and outreach and undergraduate or graduate research into research proposals. So specifically, if you're going after funding, what are some ideas that I have? I am not an expert in this by any means. I'm just somebody who has won a few awards. And so these are just my perspectives, both me personally and just serving as a reviewer and whatnot. So there's three things I kind of want to hit on today. First, just some general perspectives on proposal writing as it relates to sort of this education and outreach type component. And then I'll talk a little bit about outreach activities with meaningful impact and then embedding research content in curriculum. So what I sort of thought I'd start with is just like if you go and you read abstracts from a lot of research proposals that have won, say from the National Science Foundation or similar type of organizations, there tends to be like a checklist that I feel like you see in these abstracts. And usually like these are some of the things that you see. So you'll see something about like, we're gonna develop a new course or a module that relates the topic of the research into our curriculum. And so that's like one thing that you see very often. The other thing that you'll often see is that the researchers are integrating undergraduate students in their research activities, which is one of the focuses of today's topic. And then the third thing that you see often is you're going to foster some sort of outreach to K-12 students or underrepresented minorities to get them interested in STEM or concrete education or construction or whatever. But if you read these proposals and you sort of use that to help you write your own proposal, I feel like you're just sort of, as a proposer, you're sort of just trying to hit off a checklist, which you don't really want to do when you're actually writing a proposal. You want to have it be meaningful to you, to your community, to your institution. So, so some of the questions I would say that you might want to ask yourself is, are the activities that I'm trying to propose, are they meaningful to you and your lived experiences? So, was there something that got you interested in concrete or construction or engineering, and how could you integrate that into your proposal? Are these activities going to have measurable impact on your students and your educational programs? So are you just making a course and it's just going to be offered once or twice, or are you making a module that you're going to do for this research project and then it'll just sort of disappear? What are some ways that you can really have a measurable impact on your program or your research community at large? And then the third sort of question that I think might be worth asking is, can you accomplish this? Are you sort of listing, I'm going to make this new course, I'm going to do all these outreach activities, and then you can't actually accomplish it, and so they wind up having less meaningful impact. So what I thought I'd start with is just talking you through some things that I've done when I've written proposals or things that I've seen in other proposals that have been successful in some of these areas. So let's start by talking about doing some outreach with meaningful impact. So if we start with just sort of STEM in general, that's yes, we work in the concrete industry or materials or structural engineering, but ultimately I think a lot of us have a shared mission in trying to get people interested in STEM or construction. And so some of the things that I think are worth sort of exploring is as you write your proposal, what experiences in your life motivated you? Some of you, maybe your parent was an engineer or you liked playing with Legos or whatever it might be. Is there a way that you could integrate some of those things into what you write to captivate a reviewer when you're going and writing those proposals? Because if it just reads off as a checklist, it'll become very apparent when you're reading them. How does where you live and the institution that you serve interact with the local area, the region, and the national community? So if you work in in a rural community maybe, and your university is the lifeblood of that rural region, your institution then has a lot of impact, and what sort of outreach activities you can do to students in the area can be very meaningful. Similarly, if you work in an urban environment, maybe you serve as a sort of a segue to help lift people up who are in lower economic status. So how can you integrate some of those things that are very specific to you? And then what's appropriate for the scale of the project and the group you're interacting with. So if you've got a smaller duration project or a longer duration project, that'll dictate sort of what might be accomplishable in your research program. So what I'm going to do is I'm just going to walk you through, since the reason why I was asked was because of recently winning a career award, just some of the things that stuck out to me when I was writing that proposal and how I used it in my research proposals. And hopefully if you have any graduate students or postdocs or assistant professors, this can be useful for you. So the summer that I won my career award, I think in 2021, I think Joven, maybe the year earlier, right? Or maybe the same year, yeah. And this article in the New York Times came across my desk like the summer before. And it was an article that basically said if you live in suburban environments, girls are often perform worse in science and math than their boy counterparts. And if you're in an urban environment, it's the exact opposite. And they had this fun little tool where you could go and look at these things. And so Ridgewood Village, this is the town where I live in. And what you see is basically girls outperform boys in reading by about half a grade level, but girls perform worse by about half a grade level in math. And the reason why this sort of spoke to me was, while I was writing this, I have two young girls. Here's one of them. Her name's Bella. She wants to be a dentist. So I'm reading this and I'm thinking, like, what can I do to promote engineering and science for, my daughter or her friends or whatever, and how could I potentially have an impact on my personal community? And so that was a way that I sort of tried to, I integrated some of those things directly in writing in my research proposal, and talked about, how I wanted to pose that exact article and some of the data that was with that, and talked about going into my local community to educate girls. And so I've been doing some work with the Girl Scouts of the US, and this was sort of recently. They were making some dome structures with their second graders, so they're 8 years old. They were making some dome structures and learning, about tension elements, compression elements, how trusses work, these sorts of things. There's also a slice of an RCPT specimen there. We're just loading it with with that, but you can see the reactions. The yellow smiley faces. And I've been doing other things with them as well. So it has to be age appropriate, right? An 8-year-old isn't going to understand cement chemistry or those sorts of things, but you can relate concepts that are pretty basic, brittle ductile behavior, stability, these sorts of things. And what I'm doing here is not anything novel, right? But I'm trying to figure out a way, or I'm trying to take something that's of interest to me and integrate it into my local community based on what I feel like could have a big impact. And so I think trying to tell that story when you're writing a research proposal is really important, such that you captivate a reviewer. So it's interesting. So I live in a suburban environment, but I work in the city of Newark, and Newark is a very poor community. So it's the third neediest city in the country. And so we're also doing a lot of outreach through my career program. We're working with some charter schools in the area and getting students who are of very low means into our research programs as well. And so I think the reason why I'm putting up both of these things is they could tell totally different stories, and you don't have to just fit sort of one group into your proposal. Just try to figure out what might have a meaningful impact to you and to your institution, and try to integrate that into your research proposals. The next thing I'll talk about is sort of just thoughts on embedding research content into curriculum. So, oftentimes we're reading some of these, again, back to the proposal abstracts, or you're reading a proposal for a friend, and you might sort of think to yourself, I've got to develop this new course, and the amount of work that goes into that is really significant. The first time you do it for, say, undergraduate reinforced concrete or materials class, it's really significant. And so you have to think about what might work in your academic programs. Do you have space in your academic curriculum to actually put this in? A lot of times, you don't. You're limited to so many credits. There's only so many electives that are offered. And so one of the questions that's probably worth asking is, can you embed topics into what you already have? Maybe I don't need 18 weeks on a subject, but maybe there's a way that I can take the research that I have and integrate it into an existing lab course or an existing undergraduate course or whatever it might be. So one example was actually from when I was a graduate student. I did this for a class that I was a part of. And so the class was actually a graduate course in basically the course was in strut and tie modeling, design and behavior. And so there was an experimental component to it where basically students had to design a structural element that was abnormally shaped. They were given some bounds to it. It has to carry this load. You're going to use this type of concrete, et cetera. You had a typical reinforcement. And then they designed it, and then we tested in the lab. And so like a typical design looked something like this. Okay? So if you're familiar with strut and tie modeling, there's regions where you put tension and compression, and you design your structural elements to carry those loads. And then this was like a typical student group reinforcement layout. So they only had access to, it was a small scale, right? So they only had access to like wire and some small number 3 or number 4 bar. And what myself and my colleagues were doing in the background was we wanted to figure out a way, how could we integrate some of the research that we do into this? And by way of like introduction, my research is primarily in fiber reinforced concrete. I work a lot with UHPC and other types of systems. And so we were trying to think of a way like, how could we show the students, how this new material could be used in a unique sort of setting? And so all the students are building these forms and making their rebar layouts, and they look like that. And myself and someone else had another one off to the side that just looked like that. It was really, and they're thinking like, did I do the calculations wrong? Like, I must, something must be really off or whatever. And we didn't tell them until like after, there was a day when they presented all their results and whatnot. We went and we showed them the results. And so here's basically what the results looked like. All the student groups were those gray lines. They had to design to that 10 GIP load. And you see basically everybody made it. Some were more ductile than others. But what we were able to do was show them, when you have a new material, here's some opportunities or a new way of designing something. Yes, we did a demonstration and we talked about, okay, here's the upfront material cost that would happen, but think about how many hours you spent bending those wires and getting them into that formwork and whatnot. And I think it was a really nice experience for the students to do that. And then additionally, a part of the project was to do some computer modeling with it. And so the students were able to see, like in the black line, that was the experiment. The red line was the computer model, the finite element model that we built with it. And then we just showed them, if I made this same thing with just bare concrete, what would happen? And they could see, okay, it wouldn't have reached the, I didn't make a mistake when I was bending all those wires. You were just using, something unique and new. And so I think, this is an example where the students, had never been exposed to this material at all, and it was just an add-on, 20-minute sort of demonstration and lecture where we talked about, here's a new material, here's how we were able to use it in a sort of a setting that you had, and then that sparked a lot of discussion and interest in subsequent meetings. And so there was not time to add a whole new course on this, but it let students sort of get their brains ticking and think about what might be of interest. One of the things that I'm doing right now, so in my institution, we have a very high percentage of our graduate students work full time. So they work in like the New York City area as structural engineers. About three and four of our students work full time, either for an engineering firm or construction or whatever it is. And so for the project that I have right now, what we're doing is we're looking at as part of an existing course, they're doing a project where they're looking at the use of new materials and how they could use it in their day-to-day practice. And so that's a way that I integrated, my current research in the setting of my students. So I'm trying to take what we already have available to us and have them reflect on their experiences as practicing engineers or those in the construction industry and think about ways that they can do that. So they have some projects with that. And so in summary, so I would avoid trying to meet a checklist when preparing a proposal. It can be helpful to figure out, what are some things that I might be able to have an impact on, but really think less of it as a checklist and more about what are some potential ways that I can have an impact both on those around me, my education, my students, et cetera. And then, really try to be authentic and meaningful in the activities that you propose. Just saying that you're going to, get underrepresented minorities or women or whatever it might be interested in a particular topic isn't really meaningful unless you can figure out how does that connect with me and who I am. And then develop content that's appropriate for your academic program. So I was on time for the original one. Sorry, I couldn't take up 25 minutes. But, thank you, and hopefully my perspectives were at least somewhat useful to you. So thank you.